How are you, my friends? In my channel Math CNT, a new series of videos called Pre-Calculus course will be presented. The videos will discuss the properties of some functions and their graphs, domains, and ranges with many examples. So the videos here are divided into two parts: the lecture by itself with questions at the end to try, and then the solutions. Another video will be solutions of these questions. Please, you can check the playlist, Pre-Calculus course lectures. So lecture number 1, which will start now, covers inverse functions. And directly after that, lecture number 2, it will cover exponential functions. And then from there, we can go to other lectures. So this is a Pre-Calculus course, lecture number 1, inverse functions. There are 4 objectives here: defining a one-to-one function, the inverse of a function, finding the inverse, etc. One-to-one functions. A function is one-to-one if every value on the domain has exactly one different image. It's so simple, so easy. Some functions are one-to-one, some functions are not one-to-one. So every x has exactly one different y. Not all functions have inverses. Functions that have inverses should be one-to-one. So as I mentioned before, in one-to-one functions, each x corresponds to only one y. Now here we have 2 examples using arrows. This is not one-to-one. 2 different values here in the x, 2 and 3, they have the same y value. This one goes to 5, 3 goes to 6, 2 goes to 7. So this is one-to-one function. So one-to-one function, we can define it as, if a is not equal to b, remember, a in the domain not equal to b implies f of a should not be equal to f of b. In other words, this is equivalent to, if we have the images are the same, if f of a is equal f of b, then a should be equal to b. Let's take a simple example here. If we have this function f of x minus 3x plus 7, one-to-one or not. So I can start with this, f of a is equal f of b. So I replace a in the function, and then I replace b in the function. I simplified here, cancel the 7, and then divide by minus 3, so a equals b. So this one, yes, is one-to-one. Also, we can see that in the graph after a few minutes. Now, decide whether each function is one-to-one. Let's look at this rational function, and this is the square root of 25 minus x squared. Let's take the first one and see if this is a one-to-one function. So I can start with f of a is equal f of b. Check if a is equal to b. So f of a will be 2a minus 1 over a plus 3 equals 2b minus 1 over b plus 3. Cross multiply, just normal multiplication from algebra, and then simplify until you get 7a is equal to 7b, divide by 7, so a equals b. Yes, this is a one-to-one function. Now the second one here, if we choose a equals to 3, b equals to minus 3. See, 2 numbers different. Let's find the images. Images means I put f of 3 in the function, I get 4. If I put f of minus 3 in the function, I get 4. See, 2 different values, a 3 and minus 3, they get the same image. So a not equal to b, we get f of a is equal f of b, which is not one-to-one. Also, if you can use the other formula there, if f of a is equal f of b, then you get the square root is equal to square root, so a will be plus or minus b. We should get only a equals b. So this is not one-to-one. Horizontal line test. It's a nice test which says if we have a graph of a function, draw a horizontal line. See, horizontal line. If the horizontal line cuts this function in more than a point, 2 or more, then it is not one-to-one. So this one here, this is the graph of f of x is equal to square root of 25 minus x squared. which is half a circle. So it is not one-to-one. Now, if we look at example 2, which graphs of functions are one-to-one? If we look at the first one, draw a horizontal line test, draw a horizontal line, draw a horizontal line. Here there's a problem in number 4. You see, in number 4, it is not even a function. I put this for a trick. It's not even a function. If you draw a vertical line, you know, from algebra, if you draw a vertical line test, it's not even a function. So we cannot ask if this is one-to-one or not. So this is yes, one-to-one, yes, one-to-one, no, not one-to-one, because in the horizontal line it cuts in 2 points, and this is not even a function. So it should be function to ask about one-to-one. Now this is a summary how to test for one-to-one. If you take all these slides before, this is the summary. Show that f of a is equal f of b implies a equal b. It is one-to-one. To show that a function is not one-to-one, find at least 2 values of the x where a not equal to b, then f of a should not be equals f of b. Sketch the graph, use horizontal line test. If the function is either increasing or decreasing on the entire domain, it is one-to-one. You can see that by graphing. Now, this is an introduction of the inverse. So we have a function f. See, we have a function f, and its inverse is f inverse. So we have this one here. This is the domain of the function f. So that's a function. F of x is equal to 3x plus 4. That's the range. If I take as an example x equals 2, replace it there, it will be 6 plus 4. That will be f of 2 will be 10. So the inverse will be another function where we replace 10 in that function, 10 minus 4, 6, so it will give back 2. So this one here, the domain of the inverse, this is the range of the f. And this one, the range of the f inverse and domain of the f. So f is a function, f inverse is another function, and this is the relation between them. Now, if we have function f, which is one-to-one, and then there is a function g such that f circle g, which is f of g of x, you know, this is composition, f of g of x is equal to x. And also g circle f of x, which is g of f of x is equal to x. For x belongs to the domain of f here, and here x belongs to the domain of g. Then we can say that g is the inverse. So if you find the composition in both ways, f circle f inverse or f inverse circle f, in both cases, you should get only x. Here we have 2 important notes, N1 and N2, related to the inverse. We can see in note number 1, f circle f inverse of x is always equals to x, and f inverse circle f of x is equal to x always. We call these cancellation properties. Here we have 2 simple examples. F circle f inverse of 7 is equal to 7 directly. You don't have to find the inverse of f. Now, note number 2 will be the domain of the f is the range of the inverse. Just remember that always. And the range of the f is the domain of the inverse. We can see that from here. You see, domain of the f, range of the inverse. Range of the f, domain of the inverse. Now let's look at example number 3. Given function f and g, and we ask, is the function g the inverse of f? Well, we have to check 2 things here. We need to check both f circle g if it is equal to x, and also g circle f if it is equal to x. So let's start. Here we have f and g. So we say f of g, we just take g, replace it in the function f, cube it, becomes x plus 1 minus 1, which is x. Yes, we'll have to continue. G of f of x is the x cubed minus 1. We replace it inside the x. So it becomes cube root of x, which is always x. So yes, g is the inverse of f. You can try the second part b here. F of x is equal to 3x minus 4, and g of x is equal to x minus 4 over 3. Let's try. We start with f of g. So I take all the function g, x minus 4 over 3, replace it in the function f. 3 will be cancelled, x minus 8, which is not equal to x. So we stop here because there is no need to continue if one composition is not equal to x. So g is not the inverse of f. Now, this is an important slide here, finding the inverse if it exists. There are 4 steps for all functions to find the inverse. And here is a simple example, just to compare the steps. We have a function f of x 2x minus 4. The first step in finding the inverse, replace f of x by y. So we say y equals 2x minus 4. Then we interchange x and y. So we replace y by x and x by y. Then solve for y. Take this y, take 4 on the other side, and then solve for y, find y in terms of the other, the x and the numbers. So f inverse will be the y that we find. We have 3 examples here to find the inverse. Number 1, number 2, number 3, and example 4. Let's start number 1. So remember the steps, guys. Replace f of x by y. So I put f of x by y here. So y will be x minus 3 over x plus 4. Interchange x and y. Okay. So x equals y minus 3, y divided by y plus 4. Cross multiply. So we have xy plus 4 is equal to y minus 3. So what do we do now? We need solve for y. So this is a y. Take a y on the other side. Take x on the other side here. All right. So we rearrange the equation. Take a common factor y. Then bracket x minus 1 is equal to minus 4x minus 3. So this is the y, minus 4x minus 3 divided by x minus 1. That's the inverse. Now you can find another form. You can multiply up and down, remember, up and down by minus 1. So you get 4x plus 3, and here we get minus x plus 1 or 1 minus x. This is the same inverse, just another form. Now let's look at part 2, the cubic function, f of x is equal to x minus 2 all cubed. Replace here, you can see replace f of x by y, interchange x and y, take the cube root of both sides, so cube root of x will be y minus 2, solve for y, this is the y, that's the inverse. Now number 3, in example 4, it's a parabola x squared minus 5 shifted down 5 units. If you draw a horizontal line test, it's very clear that the horizontal line, it will cut 2 points. That means this function has no inverse. Now, this is a caution. Please do not be confused with the minus 1 in the function, in the inverse. When we say f inverse here, see we say f inverse, it is not equal to 1 over f, like the negative exponent, 5 to the power minus 1, 1 over 5. 3 to the power minus 2, 1 over 3 squared, 1 over 9. But this is in the function, that's a symbol for the inverse. Now here's an important slide. If we have the graph of the function f, we can draw easily the graph of the inverse. Why? Because every point on the graph of f, read this please, if AB belongs to the graph of the function f, like this point, then interchange x and y, 4, 2 becomes 2, 4. It belongs to the graph of the inverse. So these two graphs, they are symmetric with respect to the line y equals x, the line that passes here in the bisector. So that's so important property. Let's look here at the function f of x 2x minus 4. Graph the given function and its inverse on the same axis, and see where the graph of the inverse is below the x-axis. We know this is a straight line, f of x is equal to x minus 4, so we can graph it, just take x-intercept, y-intercept, take any 2 points you like. If x is equal to 0, y will be minus 4. If x is equal to 1, y will be minus 2. So this is a 2 points, that's f. See, it's 1 to 1. The inverse was found before. I will show it to you again here. Y equals to x minus 4. 4 steps, you get the inverse. Now let's continue on the next slide. So I can take this point here. You see 1 minus 2 I can interchange -2 and 1. And this is 0 minus 4. I can take -4 and 0. So easily I can find the red graph here. The red graph is the inverse. And this one is the black is the F. And this blue dashed y equals x. So now what do we have to do? The inverse now, this is the red graph, where the graph of the inverse is below the x. So we have to find this point here. See, this point is the x-intercept. See, the x-intercept of the inverse, look. It's the y-intercept of the function f. So since the x-intercept of the f inverse is -4, then we can say that the graph of f inverse is below the x-axis on the interval -∞ to -4. Now, example 6 is very important. We have a function, f of x is equal x squared plus 2x minus 3, and there is a condition here, x less than or equal to -1. Find the inverse, graph both functions on the same axis. Now, this is a parabola. This is a quadratic function also, which is not one-to-one. Because of this condition here, it becomes 1-to-1. So we take the function here, x squared plus 2x minus 3. You see that function there with the condition. And then there are two ways we can make this function in standard form. So I can take h and k. You can review the algebra course lecture 34, please. H will be minus b over 2a. See here from minus b over 2a, it's -1. K will be f of h, f of -1, replace -1 there, get -4. Now this is the equation for standard here. See this yellow standard, x plus 1 squared minus 4. Or you can do completing the square. You see, you take the coefficient of x, this is already 1, divide by 2, square it, you add 1, subtract 1, then you continue. So look at the condition now. This function here, without a condition, it's a parabola, complete parabola. You see, shifted on the left 1 unit and then down 4. See, that's a complete parabola. Why we took this part? Because of the condition x less than -1, less than or equal to -1. So this is half the parabola. So the domain of the f, see, this is the function from -∞ to -1, which is exactly the condition. That's the domain of the f. Now let's find the inverse on the next slide. You know the steps, 4 steps. See here I said, so still again, this is the function f. See, f x plus 1 squared minus 4. So the domain of the f from -∞ until -1, and the range will be from -4, which is the k, until infinity. Now let's see the inverse. Put f of x, y, interchange x and y, and then take the square root of both sides after you take x on the other side there. So it becomes y plus 1 is equal plus or minus square root of x plus 4. See, here we have two functions for the inverse. We have to choose. We cannot write f inverse of x is equal -1 plus or minus square root of x plus 4. Only one of them will be the inverse of this black. So we have to choose the inverse, either the plus or the minus. We have to check. Just checking, make sure the domain of the f is the range of the inverse, or I can show you another way here to check. I can take any point on the graph of the f. You see this f here? If you take -2 there, replace it in the f, put here -2, what do you get? -3. See here, put -2, square it, so that's 1. -4, -3. Now interchange -2, -3 in the f, -3, -2 in the inverse. It's a point on the inverse. So I can take the inverse in the positive and then the inverse in the negative and see which one is the inverse. See, I take the positive here, so it becomes f inverse -1 plus square root of x plus 4. And here the -1 minus the square root of x plus 4. See here I replace from the inverse here, -2 in the y, and the x is -3. -3 plus 4, that's 1. -1, 0 is equal -2, no. So this is not the inverse. So when I replace here -2 and -3 there, so that's -1, -1, -2 is equal -2. That's the inverse. So I can take now the inverse. You see? So X will be, the domain here of the inverse will be the range of the F. You see the range of the F. So the black is the given function and the red is the inverse. Really nice question. Number 7, function minus square root of X minus 2. Let's find F inverse of -2 plus F inverse circle F of 14 plus 3 over F of 3. Let's find all these values. See which one is easy. This is easy. F of 3, just replace 3 in the function. This is in the middle here. It's always 14 because this is cancellation. Now this one I will show you 2 ways to do it. To find F inverse of -2, inverse can be found. You can find the inverse of this and then replace X equals -2 in it, in the inverse. That's one way. Another easy way I can show you, F inverse of -2, use -2, this -2 here, as the Y value in the function F. See, this is the X value in the inverse. You see? F inverse of -2, that's X. Use it as Y in the function. So -2 is equal minus square root of X minus 2, square both sides, and you get X equals 6. So F inverse of -2 is 6, this one here. You will get the same value if you do the normal way. What is the normal way? Find the inverse. Inside the inverse, you replace X by -2. Let's continue now. So this is the middle part here. This is note 1. That's 14. To find F of 3, just replace it. X equals 3 in the function. So F of 3 is equal minus square root of 3 minus 1. So this is -1. So I put here -1 down. And here is, I get already 6 and 14. So the answer is 17. Now I will leave for you some questions here. I call them old exams questions. You can call them practice questions. In the second question, F of X is equal cube root of X minus 8 minus 3. Graph the given function and its inverse, where the graph of the inverse is above the x-axis. Here we have function g, 3x plus 2, and function g also is equal to 2f inverse of x, where f inverse is the inverse of the function f of x is equal ax plus b. Find the value of a times b. You can do that. Number 4, we have a function rational, mx minus 2 divided by 4 minus 5x. Find the value of m if f inverse of minus 23 is equal to 1. After that, you can find the domain of the inverse. Here we have 2 functions given, f of x 1 over 8 x minus 3, and then g of x is equal x cubed. Let's find g inverse circle f inverse of -4 and f circle f inverse of 27. Question number 6, we have a function, quadratic function, that's a parabola. They have a condition here, x greater than or equal to -2. Graph the function and its inverse and tell me where the graph of the inverse is below the x-axis. Here we have to find the inverse of 4 functions, number 1, number 2, number 3, and number 4. There is a condition here in number 4. Now here is the answers for the old exams questions and all their parts. You will see like this slide at the end of every pre-calculus lecture in the whole course. So just I want to mention, please, for complete solutions of these questions and their parts, please, you can see the video on inverse functions, pre-calculus, old exams questions. Thank you for watching. If you like the video, you can subscribe and share it with your friends. Just to remind you that this is pre-calculus course. This is lecture number 1. Thank you again for listening.